Hello students, this is Shailaja Vibhute, lecturer, KLS Gokte PU College of Commerce and Science, Belagavi. In the last video we have learnt when two resistors are connected in parallel, how to get expression for effective or equivalent resistance. When two resistors are connected in series, current remains the same, potential divides, then total resistance is equal to sum of individual resistances. Related to this series combination, there are some points. When two resistors are in series, then Rs is equal to R1 plus R2. If n identical resistors of resistance R are connected in series, then how will you write? Rs is equal to R plus R plus R plus so on to n. So Rs is equal to n times R. Law of resistances in series means when a number of resistors are connected in series, the equivalent resistance is equal to the sum of individual resistances. Means you have to write the conclusion of your derivation. That is law of resistance in series. In series combination, the effective resistance is greater than the highest value of individual resistances. One more point you can remember here. For a series combination of resistors, the circuit is potential divider circuit. Now let us learn when two resistors are connected in parallel, how to get expression for equivalent resistance. Here you are observing two circuit diagrams. In first diagram, there are two resistors. One is R1 and another one is R2. Now two resistors are connected in parallel. V is the potential difference applied across the combination. I is the main current flowing in the circuit. I1 and I2 are two currents through R1 and R2 respectively. Second circuit is called equivalent circuit. Two resistors which are connected in parallel can be replaced by a single resistor and it is called equivalent resistor, and we will represent it as Rp, but in circuit it is only R, you write it as Rp. Rp is equivalent resistor, I is the same current which is flowing and V is the potential difference. Then you have to apply Ohm's law. What is Ohm's law? V is equal to IR. For parallel combination, total current I is equal to what? I1 plus I2. Now when you apply Ohm's law for the first resistor, for first resistor R1 is the value of resistance and I1 is the current. V is potential difference. So when you apply Ohm's law, you will get V is equal to I1 R1 or I1 is equal to V divided by R1. Similarly, apply it to second resistor. I2 is equal to V divided by R2. Now substitute it in equation 1. What you will get? I is equal to V divided by R1 plus V divided by R2. Which is common here? V is common. So I is equal to V into bracket 1 by R1 plus 1 by R2. Let us name it as equation 2. If the combination is replaced by effective resistor of resistance Rp, Apply Ohm's law again. What you will get? V is equal to IRP, or I is equal to V divided by RP. Let us name it as equation 3. Now just observe equation 2 and equation 3. LHS is I. RHS you can equate. When you equate, what you will get? V by RP is equal to V into bracket R1 plus R2. So we get cancelled. What you will get? 1 divided by RP is equal to 1 by R1 plus 1 by R2. So what is the conclusion then? When a number of resistors are connected in parallel, the reciprocal of equivalent resistance is equal to the sum of reciprocals of individual resistances. So after comparing equation 2 and 3, what you will get? V divided by RP is equal to V into bracket 1 by R1 plus 1 by R2. V get cancelled. You will get 1 divided by RP is equal to 1 by R1 plus 1 by R2. So this is expression for effective resistance when two resistors are connected in parallel. Now relative to parallel combination, here there are some points. Try to remember. When only two resistors are connected in parallel, RP can be written as RP is equal to R1 plus R1 R2 divided by R1 plus R2. Actually formula is 1 by RP is equal to 1 by R1 plus 1 by R2. That only you can write it as RP is equal to R1 R2 divided by R1 plus R2. This form of equation will help you to solve the problems. If n identical resistors of resistance R are connected in parallel, then RP is equal to R divided by n. And here law of resistance in parallel is when a number of resistors are connected in parallel, the reciprocal of equivalent resistance is equal to the sum of reciprocals of individual resistance. The parallel combination of resistors is current divider circuit. Series combination is potential divider. Parallel combination is current divider. So you have completed now both series and parallel combination. Now you can distinguish between series and parallel combination of resistors. If you know these points, even practicing the derivation is also very easy for you. So in case of series combination, it is end-to-end connection. For parallel, it is the connection between two common points. Current remains same in case of series combination. Potential remains same in case of parallel combination. So series is potential divider circuit. Parallel combination is current divider circuit. For series combination, total potential V is equal to what? V1 plus V2 plus V3 so on. For parallel combination, total current I is equal to I1 plus I2 plus I3 so on. Effective resistance in case of series is Rs is equal to R1 plus R2 plus R3 so on. In case of parallel, it is 1 divided by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 so on. This combination increases the effective resistance. For parallel, it is decreases the effective resistance. Now here is one note. The series combination of resistors is used in the resistance boxes and in decorative bulbs. The parallel combination of resistors is used in household electrical appliances. So both the series and parallel combination derivations are important. Try to practice. Related to parallel combination, one more formula you can learn, that is called branch current formula. When two or more resistors are connected in parallel, the current through each resistor is called branch current. Means in the circuit diagram, I1, I2 are called branch currents. How to find I1 and I2 then? For that there is a formula. Current in one branch is equal to main current into resistance of other branch divided by total resistance. Let us try to apply it to I1. So I1 is equal to what? Main current. Main current is I. Resistance of other branch. Resistance of other branch means it is R2 divided by total resistance R1 plus R2. Similarly, if you want to write for I2, it is I2 is equal to IR1 divided by R1 plus R2. So branch current formula to calculate I1 and I2, you can remember the formula. It will help us to solve the problem. Now let us try to understand most important word, that is called EMF of a cell. EMF means electromotive force. It is the work done by a cell to drive a unit positive charge throughout the circuit. SI unit of EMF is volt. Actually, EMF is not a force. It is energy spent or work done. It is called EMF as this energy motivates the electric charges to flow with force. Now let us see what is internal resistance of a cell. Usually it is denoted by the letter small r. It is the amount of opposition to the flow of current offered by the electrolyte and electrodes of the cell. Its unit is ohm. I hope you have heard the word like short circuiting. What is meant by short circuiting of a cell? I hope you know this one. In a cell, two electrodes are there. One is positive, another one is negative. If these two electrodes are joined, means positive and negative is joined externally, then it becomes short circuit. So if the electrodes of the cell are connected from outside in a circuit having negligible resistance, it is said to be short circuited. You can see in the diagram one red color line you are observing. Here both positive and negative are joined. If the cell is short circuited, it gets discharged because of very heavy current will be drawn from the cell. Now let us see the difference between EMF and potential difference. EMF is energy spent by a cell to drive a unit positive charge completely round the circuit. Potential difference is work done to drive unit positive charge from one point to another point. EMF depends on the nature of electrodes and electrolyte of the solution. Potential difference depends on the resistance between 2 points in the circuit. EMF is greater than or equal to potential difference. Definitely potential difference must be less than or equal to EMF. EMF is the cause, potential difference is the effect. Say if you have one cell, the value of the cell is written on that one, that is 1.5 volt. This 1.5 volt is EMF. When you connect that cell in a circuit, and if the component uses that 1.5 volt, then it becomes potential difference. So total value written on the cell is EMF. When it is connected in the circuit after utilizing, it becomes potential difference. Hope these points are clear. Thank you.